This is a presentation on the .NET Programmatic Interface for Open Automation software. I will demonstrate for you how to read and write to OES tag values that can be defined to any Industry 4.0 data source. I'll show you how to programmatically add tags, how to implement networking so you can deploy your applications remotely, and I'll show you where to download example source code from the website at openautomationsoftware.com and how to deploy the applications to both Linux and Windows. If we visit the website openautomationsoftware.com, in the upper right we'll select Support Knowledge Base. From the Programmatic Interface section at the left, expand that, and then expand .NET Real-Time Data Access, and there you'll see an article for Example Service Code. At the very top is where you can download the example source code. The rest of the information listed in this article is relative to that source code, breaking down the summary of each method. You can extract the file to any directory of your choice, and there you will see 4 projects, 2 for .NET Core console applications and 2 Windows Service applications. If you're only deploying to Windows, I would suggest to deploy as a Windows service. Otherwise, if you're going to deploy to Linux, Windows, or possibly build Android or iOS applications, use a .NET console application. You can then open the projects with Visual Studio. If you don't have a copy of Visual Studio, you can get a free version downloaded from the Visual Studio community page. Just search the internet for Visual Studio Community. I'm going to use Visual Studio 2019 and open up one of the projects. I'm going to choose the .NET Core Console and the C# project. The first thing I want to show you is in each project, you'll see in the dependencies section, you'll have 2 critical assemblies that are included. One is the OES config and the other is OES data. The OES config assembly is used to set and get any OES configuration attribute, and it is free to use. The OES data assembly is used to read and write real-time data and does require a license of the OES.NET data connector where the engine is running. And the location of these files is where you have installed Open Automation software, which by default is in Program Files, Open Automation Software, OAS. These assemblies are both .NET Standard 2.0, which can be implemented in applications that target .NET 5, .NET Core 2.0 or greater, .NET Framework 4.61 or greater, Xamarin iOS and Android applications, and Universal Windows Platform applications. If you need to deploy to an application to target .NET Framework 4.6 or less, you can use the legacy OPC Systems.dll for configuration and the OPC Systems Data Connector.dll for data access. All methods are implemented in both assemblies. Looking in the project, if we open up the code OES Demo Service, at the top of the code we can see we have a reference to the OES data and OES config assembly. If we search for the OES config variable, the first thing we see is a check to see if the service is in runtime. If it isn't, it'll exit. The next thing we'll find when we search for the OS config assembly is a function called setTagProperties. And with this method, what we're going to do is we're going to programmatically create tags in the remote service. We're going to create 3 tags in a main group called OES Demo Service and in a subgroup called Service Tags with the tag names ramp, random, and sign. We'll also see a second call to set tag properties to create 14 additional tags. With my local service running, what I'm going to do is open up the Configure OES application and go to Configure Tags. I'm going to select the local service, and there I see I have my demo tags. I'm going to delete all of those demo tags so that we're starting from scratch. And then let's run the code. There we can see the application has started up. If I go back to the Configure application and select localhost again, I see I have a new group called OES Demo Service, and I have that new subgroup called Source Tags. There I have ramp, random, and sign. I have some additional groups called async read, async write, sync read, and sync write. Those are to demonstrate the data access methods on the OES data component. So if we take a look at, say, the double variable of the async write, we can see that the value is changing frequently, even though the data source is value. And that is because the .NET application is indeed writing to that. So if I close the .NET application, we see that the update on that value stops, even though the source tags are still updating. In the next section of code, we see we can write tags asynchronously. That is the most efficient way to write to tags. Let's expand that section. And there we have the simple method on the OAS data variable called write tags. And with that method, we're simply passing in an array of tag names, which are strings. And we can see these are the three tag names we're writing to, the Boolean, double, and string. And the second parameter passed to the write tags method is an objects array, which would contain the values that we want to write to those tags. The values that are being passed are just randomly generated. So if we run the code again and go back to the configure application, we can see that the values are being updated on those tags again. We can just add those variables to the watch so we can watch those. With the write tags method, you can also optionally include timestamps. This will allow you to specify your times from the .NET application as the timestamp for each individual value that you're writing. This will then be passed through the OAS engine through the first in, first out processing to carry that timestamp with 100 nanosecond resolutions all the way to the destination. If the data source of a tag is defined to a controller or an interface type, the values that you write will be written down to the controller or interface. Let me just show you a live example of that. Let me define quickly a Modbus interface under configure drivers. I'll just define this to a local emulator that I'm going to run on my system. I'll just add that driver. I'll just select any tag that I would like. Let me start up the emulator. Let's get back to run the code, of course. And there we see the value is updating with the data source set to value from the .NET application. So now, if I set the data source to Modbus and define this to holding register 1, let me take a look at that emulator as well. When I select apply changes, you see now the value is being written to the emulator, but we do see we've lost a little bit of resolution. That is because the data source that we're reading it back from is a 16-bit integer. So we're writing a floating point number, but we're losing the decimal points due to that the source itself is just a 16-bit integer. Now, of course, with Modbus, you can set it to a float 32 or 64, or we can use the gain property. Let's set it to 0.01 and apply changes. Now we see that the value that is being written is multiplied by 100, and then when we're reading it back, it's divided by 100. So that's some simple scaling. That's an example that whatever your data source is, when you call the write tags method, the values will be passed on down to the source that you have defined. Now we can also read these tag variables. If we go back to the code, the next section talks about how to read tags asynchronously. This is the most efficient way to monitor tags continuously. The first thing we'll see is that we're calling add tags on the OAS data variable to pass in the tag names that we want to monitor. And these are coming from the source tags. When we do this, the values will then be passed on the event. Let's go find that event. If we just search for the OAS data variable from the top of the code, we see that an event handler is defined called values changed all. And then this is the method that's defined to handle that. And what's passed to us is an array of tag names, an array of values, an array of qualities, an array of timestamps. Each time that any of the tag values change that we have subscribed to. Now you can call add tags multiple times, simply adding additional tags at any time you like within your code. If you want to remove tags from the subscription, simply call remove tags. In this code example, we're simply putting it into a queue that contains a class of arrays of tags, values, qualities, and timestamps that are then processed on this timer. In this timer routine, we'll see that the arrays are being checked. Here, we're checking to see if the quality is good. If it is good, we're just updating the value to a local hash table. If the quality is bad, we're removing that value from the hash table. This is just an example of where you could then, in your own code, then access this hash table for the latest value that's being monitored. Also, further down in this timer routine, we see that if the data source is ramp, we're going to write to the async read subgroup the tag called ramp within it, the current value that's received. Now, if the quality indeed was bad and was null, when we write to a tag that has the data source of value, the quality will be null. So here we don't really need to check the quality because we would indeed want to pass in what is the value we're currently receiving from that source tag. So if we run that code again and go back to our configure application, and let's go to the group async read, we see that these values are being updated from what we're seeing as a source. We go back to the code. The next section down is a simple write tag. It is demonstrating a single write, which we've just discovered, and it is using the time, passing a timestamp when it's doing the write. The next section is a synchronous call. Even though this is not as efficient, it is a blocking call. If we look at the OES data variable, we have the method sync write tags. Same format as the asynchronous write, passing in array of tag names and array of object values. But we also get a error feedback, which is an integer array of each individual element. And if the service is not reachable, that value returned for those items will be 1. Of course, if there's something incorrectly defined with the array size, value of 2, a value of 0 indicates that the values have been successfully passed to the service, but it does not confirm that the value has been read back from the data source. It only confirms that the write has been handled off to the service itself. If you want to confirm that the values have been delivered all the way to the data source and read back as what you have passed, you can use the function sync write tags with confirmation. And with that, you can then optionally specify a timeout, which defaults to 10 seconds, and also optionally specify a deadband for floating point numbers. If the value has been read back from the data source, the same value that you're writing, a return index will be of a value of 0 for that individual element for that specific tag. A non-zero number being fed back from that index array would indicate that there was a problem, that the value either didn't read back within the timeout period or possibly the service wasn't reachable. In the next section of code, we see how to read tag synchronously. This is a function that you can use to read values just once, or of course multiple times, but it is going to be a blocking call. So it's not as efficient as the asynchronous method, but it still is quite fast in return. If we look at this code, we see the tag names that we want to read are simply those source tags. So we're going to pass in those tag names. Then we're going to pass in an error index by reference, an integer array. And when the values are returned, we can check that index array, that integer array, for the values to be either 0 with good quality, here we have that, or if they're non-zero, would be bad quality, either due to the data source being bad, maybe the service is not reachable, or the tag name was not defined correctly. Here in the code example, we're calling sync read tags, and then we're using the values array, and when the quality is good, we're just setting a local object variable to that value. And then we're calling the single write tag to the tag name that we want to write to. Those tag names are defined here, that if the source tag ramp is the tag that we're reading, then the tag we're going to write to is called sync, is in the subgroup sync read, and then ramp. So let's run the code. Then if we go back to the configure application and we look at the subgroup sync read, these are the tag names that we're writing to. So you can see that method is being called roughly every 100 milliseconds and returning from the local service. We can read and write to more than just the value property of a tag. Value would be the most common, but we could also read or write to the description, units, maybe the high alarm limit, check to see if the alarm is active or not. To see a complete list of all tag variables that you can access using the data component, visit the website at openautomationsoftware.com. And under the knowledge base, under data sources tags, you'll see an article for tag variables. And there you can see a complete list of all possible tag variables that you can write to. I want to show you a quick way where you can actually browse for those tags to get the full variable syntax of a tag. You could use any of the OAS tag browse features. I'm going to show you one quickly here under the configure application. If you change the data source to tag and then select browse, you can browse for a local or remote tag. We'll select that service. And then we can see we have the demo service. We want to look at the source tags of ramp, and there is value. And so that is the full tag path for that local tag. I mentioned at the beginning of this video that you could also deploy your applications remotely. That's very simple. If we use this tag browser, we can see the syntax on how to make that happen. Here I have a remote service which is running on a Raspberry Pi 4 device running Linux. And I can select that remote node, and there if I select value, you can see it puts in double backslash and then the IP address and then backslash in front of that tag name. Then you would just simply include that tag as your full tag in the source. So if we go back to look at the code, this would be an example tag name where we'd put in double backslash and then of course the name of the name tag. Of course with C# you're going to have to put in 4 backslashes because the backslash is an escape character. So this would be an example of a full tag path referencing the OAS engine running on that Linux system. So the first example of networking I've showed you is if we have basic networking where the OAS engine is running on a system that has a static IP address. If it doesn't have a static IP address, you can use the live data cloud feature, and then you would use this notation to access the tag variables. If you want to learn more about the live data cloud feature and of course the syntax, let's go back to the knowledge base. And then we have the group called networking, and if we expand that, there you can see the basic networking syntax and then of course the live data cloud networking syntax. If you wanted to redirect all communications to a different node, and this you could use the method add network node alias on an OAS data network nodes variable. Let me go back to the code and I'll show you how to implement that. So if we look at where the OAS data variable is assigned to that values changed all event handler, we're going to put in the code of the add network node alias. So we're going to instance an OAS data variable that's assigned to the OAS data.network nodes. We'll just construct that, and then we'll call the method anywhere within the code add network node alias. What I'm going to do here is reference any tag that's defined to a local service to a remote service. So I'm going to connect this to that remote system. It's running Linux. So that takes care of the all data methods for asynchronous and synchronous calls. So any tag that's referred to a local will be redirected to that remote node. But there's also the OAS config assembly as well. So let's take a look at the OAS config variables and let's search for all instances of that. So what we'll need to do here is also include that remote node. This is the IP address of that system. So we'll check to see if it's in runtime. Then we'll also see, we have the set tags property function. Have that twice. So we'll replace localhost with that new IP address. And then we'll run this code. So now the .NET application is communicating to the remote system running Raspberry Pi 4. So if I come back to the configure application and under configure tags, I'll select that remote node. And here we have the demo tags that are already running, but we also have this new group that was added using the OAS config variable called OAS demo service. And there we have the async read or async write. And we see that the values of these tags are being updated from the .NET application. So if we add this group to the watch, we can see here that the .NET application is writing to those remote tags on the remote engine. We have the local tags that are no longer updating because the .NET application is not referring to those. Instead, it's writing to the remote tags here. And then we're just reading those values back here in the watch window. So let's move this over. And so when we stop the .NET application, we see that those values indeed stop updating because the .NET application is no longer running. Communications from a client application to a service implement binary TCP communications with compressed and encrypted packets. And also, you can secure your OAS engine using OAS security to define particular users that have access to configurations and data. And if your engine has security implemented on it, you will need to call the login methods on both the OAS data assembly and the OAS config assembly to pass in the various username and password that have the proper credentials for access. When you're ready to deploy your .NET Core console applications, you will want to publish them as self-contained. So under the project, you'll select Build and then Publish. You can then specify a local folder to publish it to. Choose any folder of your choice. You can then, of course, rename this to whatever you would like to call it. If we edit the configuration, we can then set the deployment mode to self-contained. That's important to make sure it includes all the files needed to run the application independently. And then we'll also set the target runtime that will match up with the processor that you're going to be running on. When you deploy your system, you can register the application so it runs automatically when the system starts up. A good example on how to do that for Linux is under our knowledge base. Under the data sources, you'll see how to write a universal driver interface. And with a universal driver interface, we have an article called Deploy Linux Raspberry Pi 4. So the universal driver interface is used so you can create your own device driver for OAS. But it also has this great article. If we scroll down, we can see how to configure and run the drivers as a Linux service or daemon. And so here are the steps that you need to do on the Linux operating system. You will need systemd, so you can install it with this command. Then you would set up a user to run the application under, and then you'll define this file that you'll then place in etc systemd system subdirectory. And then you'll restart the device and your application will automatically run. If you're running on Windows, I would recommend to run as a Windows server. Let's open up one of those projects. So I'll go back to Visual Studio. And I'll look in the OAS Windows Service subdirectory. And we just open up either Visual Basic or C#. So if you want to change the name of your service, the first thing I'd recommend to do, of course, is to change your assembly name. I'm going to call it My Demo Service, just as an example. Here under the project properties, and then we have the application dialog. And then if we go into the design mode of the project installer, we'll see a component, Service1 Installer. And there is where we can define in the description, display name, and service name properties what the service name that we want it to be. This would be your own service. And of course, you can run as many applications to an OAS engine as you like. There's unlimited client connections, so you could be running multiple services in the background, talking to the same engine or different remote engines. So now what I'll do is I'll set this to release mode and build. Then I'm going to use the Visual Studio command prompt and run install util to register the service. Make sure you use the Visual Studio command prompt because it has a path to the install util application. I'm going to browse to that directory where my application has been built or deployed to. It's in this directory. And then I'll type install util and then the name of the file. My demo service is what we called it. And the Visual Studio command prompt does need to be run in administrator mode to have access to register the service. So we see that registration is complete. If we now bring up the built-in service control manager of the operating system, we go down to my demo service. There's the new Windows service that's been registered. So now when the system restarts, this service will start up. If you want to unregister it, just simply put /U, and that will unregister the service from the operating system. So we come back here to refresh this. We see that my demo service is now gone. If you have any questions of what you've seen within this video, you can contact us under the support page. Select Contact Us. You can send an email to support@oasiot.com, and we'll be happy to visit with you online to discuss any of your application requirements.